Hello, class. I would like to begin the Lab 3, giving you Lab 3. I'll put this up in a little while. I've had quite a few things going on this past week, so I haven't been able to get to Lab 3 as quickly as I wanted to. I had to spend some time at Leahy Clinic that nobody wants to spend. And I was pouring some foundation footings, so there were two things that were going on. But I've got Lab 3 all set up. In fact, I want to share a screen with you. In fact, I think I can bring up two screens that I am going to share with you. Although really I only have to bring up one because you'll see it on the top of the one anyway. All right, let's share this screen. Okay, as you can see with this is just a website. Up here, you can see the URL that I want you to go to. Just type that in, colorado.edu/sims/html/forces in motion basics/latest/forces in motion basics_en.html. If you can't see that, but I think that you can. Go to friction. When you go to friction, you're going to see this. Right, so everybody sees what you're going to do. I want you to click on sum of forces, values, masses, and speed, everything that you've got there. And here's what I want you to do. I want you to, this man, he's got 50 kilograms here. I want you to leave the friction setting exactly where the friction setting is set when it starts up, okay? Then I want you to start pushing on this to move it, right? So you're going to push on that. You're going to have to obviously increase the amount of force that you're pushing on it with so that it is going to get up to, right? There's a static coefficient of friction. You can see that it's nice and bumpy here. So he's going to have to get up to a certain force to get that thing moving. Now, once it starts moving, it's going to keep moving until he decreases the force to the point at which the kinetic coefficient of friction is less. The kinetic coefficient of friction times the weight of the box is less than the force that he's pushing on it. And that's what you're going to do with this lab. You're going to figure out exactly for the frictional setting that's set up right when you get to the website. Don't change that at all. And then start pushing on it, right? So I want you to push on it so that you can figure out what the static coefficient of friction is. And then I want you to decrease that force so that you can give me what the kinetic coefficient of friction is. And I can tell you right now, the kinetic coefficient of friction always is less than the static coefficient of friction, right? Once you get it going, you want it to keep going. You don't want to stop again so that you have to overcome that whole higher amount of force that you needed to get it started. So that's what you're going to do. You're going to push on this. You're going to find the kinetic coefficient of friction, and the static coefficient of friction and the kinetic coefficient of friction for this arrangement with him pushing on a 50 kilogram weight, right? That's not the weight, by the way. That's the mass of that object, that crate. It's not the weight. Remember how you would figure out the weight, knowing the mass, of course. And that's the next thing I want you to do. After you've done that is I want you to take another 50 kilograms and I want you to put it on top of that. And I want you to find out the static and the kinetic coefficient of friction again. You're going to actually find out that one of those two, either the static or the kinetic coefficient of friction, will be slightly different because you're using a larger weight. After you do that, after you do the single one, figuring out the static and kinetic coefficient of friction, and you do the double, figuring out the static and kinetic coefficient of friction, you can put these back. And I want you to take out the mystery weight, right? And I want you to figure out, knowing the static and the kinetic coefficient of friction, I want you to figure out what the weight, or what the, well, you can figure out the weight, but really I'm looking for the mass. You can give me either one. I can divide by 9.81 meters per second squared too, but give me the mass of this package, this questionable package, right? Now, after you do that, so that's three things that you're going to do: coefficient of static friction for both this one, this one, this one. This is all of about a 10-minute lab, by the way, if you if you do it correctly and you've got a calculator in front of you. After you do those, I'm not going to have you do another 100 kilogram because you already did the 100 kilogram with the 250 kilogram weights, right? But you should be able to figure out, for this man that's 80 kilograms and for this girl who is 40 kilograms, and in fact, you just really double it because it's 40 and 80, isn't it? What the force would be to get them started moving. Like if I put the man up here and I want to start pushing on him, right? How much force would it take for me to start pushing him? And in fact, let's just do the man, because cutting it in half, that would just be redundant, wouldn't it? She's 40 kilograms, he's 80 kilograms. So what would the force be to get him moving? And then what would the minimum force be to keep him moving? All right. Okay, that's what I want you to do. You know, you can also, looking at the speed here, you can see what the acceleration is too, because force equals mass times acceleration, right? So we can always just divide the force we're pushing on him by his mass, and that'll give us the acceleration of the thing. In fact, I probably should require you to give me the acceleration once this does start moving. What is the acceleration? That's a good thing. Yeah, we'll put that in and the first one too. Figure out what the acceleration is. Let's put that up there. And then this guy gets moving. What's the acceleration that he's got just as he starts moving? Okay. Force equals mass times acceleration. This is your lab 3. I will put this up right now. Okay.